I'll show how to factor these three polynomials, first by grouping, and then I'll go back and show how to use factor by box to factor these three polynomials. If you're factoring polynomials, such as this, it's helpful to have a little roadmap. I address this in more detail in introductory videos, but basically you look for a greatest common factor. If there is one, you factor it out, and then you pay attention to how many terms you have. In this case, we have 3 terms. The leading coefficient is not a 1, but it's some number other than 1. When that's the case, factoring is a little bit more complicated than in this case, and you can use the box or you can use factor by grouping. There are other methods as well. When your leading coefficient is other than 1, you multiply the first times the last. This gives us 48. Then list all the factors of 48. 1 times the number always works. Then you just see, does 2 work? 2 goes in there 24 times. Does 3 go in? Yeah, because if you add 4 and 8, you get 12. 3 goes into 12. So 3 goes into 48 16 times. When I get to 4, I actually don't even have to go back to the 48. This is an even number, so I can cut it in half. So if I take 24 and cut it in half, I double the 2. Then you get to 5. 5 won't go in. For 6, this is an even number. Cut it in half and double the 3. 7 won't go in, and when you get to 8, you've already covered it. This lists all the factors of 48. Now when we multiplied, this was a negative 8, so we got a negative 48. And when you're multiplying, the only way to get a negative is positive times negative or negative times positive. So that means these numbers are different signs. I want a difference of positive 13. So it must be that the bigger number is positive, the smaller number is negative, and when I subtract, I'm looking for a positive 13. These two won't work. This would give me, I'll put a check mark, this pair would give me a positive 13. These won't work and these won't work. One more point to mention, I actually multiplied 6x squared times negative 8. So there is an x squared here. I just don't normally write it because it's a lot of work. In fact, there's an x next to each of these terms. You just have to remember to use the variable for the factor pair that you choose. When you use factor by grouping, you keep your first term, you keep the last term, and your middle term, positive 13x, gets rewritten, negative 3x and positive 16x. So if you see with these two terms, I've actually preserved the value of the original term and in fact the original polynomial. I've just made it look different. Now for the grouping part, you group together the first two terms, look for the greatest common factor. I can get 3x out of here and out of here. So I'm going to factor out a 3x. If I'm going to factor it out, that means I'm going to divide it out. So I'll show that here, but you don't really have to show this step as long as you understand it. I'm dividing out a 3x, dividing out a 3x, and I'm preserving the value because it's sitting in front of the parentheses, ready to multiply back in. So in this case, we would be left with 2x, and in this case, we would be left with negative 1. Then you group together the last two terms and look for a common factor. 8 can be factored out of each term. So I'm going to factor out a positive 8 from each term, which really means I'm going to divide by 8 and divide by 8. So for our first term, I'll be left with 2x, and for the second term, a minus 1. Notice how these two sets of parentheses have exactly the same thing in them. That has to happen, because now, in effect, you repeat the process looking for a greatest common factor, and the greatest common factor is this set of parentheses with 2x minus 1. So I'm going to factor out 2x minus 1, and we'll see what's left once I do that. So again, I'm really dividing by 2x minus 1 and dividing by 2x minus 1. So for the first case where we factor out the 2x minus 1, these cancel and you're left with 3x. And in the second case, these cancel and you're left with plus 8. This is the factored form of the original polynomial. I can call this a trinomial as well. It's just usually we refer to it as a polynomial. And if you're curious, this is two binomials. We'll be looking at this one in just a moment, and notice that the signs are a little bit different. Here we had a positive and a negative. Here we have negative and a negative. And in our last example, we have a negative and a positive. Our leading coefficient is other than 1, so we multiply first times the last. I should have said and we have 3 terms. This gives us a 40. I'll list all the factors. Three will not work, so no multiple of 3 will divide evenly into 40. So that eliminates some of the numbers we have to consider. 4 will certainly work. And notice that's an even number. So I can cut that in half and double the 2. I'm sure you already knew that 4 times 10 was 40, but anyway. 5 will work. Goes in there 8 times. Remember 6, it will not work. It's a multiple of 3. 7, you just have to try it and it won't work. And when you get to 8, you've already listed it. So here we have all the factors of 40. And again, it was positive times negative, so this is a negative 40. The only way to get there is positive times negative or negative times positive. We're trying to subtract our way to a negative 3, so it must be that the bigger number is negative and the smaller number is positive. So what will give us a negative 3? These two. This factor pair will combine to give us our negative 3. And remember, we multiplied an x squared, so that's really 40x squared. So there's actually an x here and an x here. With factor by grouping, you keep the first term, you keep the last term, and you rewrite the middle term with plus 5x, negative 8x. So again, we've preserved the value, we've just rewritten the middle term as 2 terms. Now for the grouping part, you group together the first two, look for the greatest common factor. It's simply an x. So I'm going to factor out x. This will leave me with 4x. This will leave me with plus 5. In this case, I have to be a little more careful. Notice I have a negative here. I'm going to factor out a negative value from each term. If I'd been a little more careful, I could have put minus 8x plus 5x, and then I wouldn't have the situation I'm faced with right now. But I'll cover it now because this is what I have. So if this term is negative, I'm going to factor out a negative common factor. So I can get a 2 and a 2 out of each term. So I'm going to factor out a negative 2 from each term. So again, I'm dividing by negative 2 and dividing by negative 2. I just didn't write it here. I'm trying to make it look a little less cluttered. I could have shown that I was dividing by x and dividing by x. But if you can do that in your mind, it's fine. But with the negative, I'm trying to be a little more explicit. So negative 8x divided by a negative 2 leaves us with a positive 4x. Negative 10 divided by negative 2 leaves us with positive 5. And notice what we have in parentheses is identical. So 4x plus 5 is the common factor. So I'm dividing out a 4x plus 5 and dividing out a 4x plus 5. In this case, it leaves me with an x. And over here, it leaves me with a minus 2 or a negative 2, however you care to see that. So this is the factored form of the original polynomial. Again, we have 3 terms, no common factor, leading coefficient other than 1. So multiply 3 times 12, list the factors, and in this case it was a positive times a positive, so we got a positive 36. The only way to get there if you're multiplying is to have positive times positive or negative times negative. So that means these signs are going to be the same. For this to be negative, it must be that everything here is negative. So we're looking for a sum of negative 13. Negative 4 and negative 9 will give us our negative 13. And of course, that's an x squared. So there's an x here and an x here. Keep your first term. Keep your last term. Rewrite your middle term with these two. Then you group together the first two, factor out the GCF, which is x. Here it leaves you with 3x, and here it leaves you with minus 4. Then you group together the second two. If this is a negative, we're going to factor a negative out of each term. So we're going to factor out a negative 3, divide by negative 3 leaves you with 3x, divide by negative 3 leaves you with negative 4. Notice what's in parentheses is identical, so I'm going to factor out 3x minus 4. So when I divide out the 3x minus 4, I'm left with x. When I divide out the 3x minus 4, I'm left with negative 3. This is the factored form of the original polynomial. So now I'll show how to factor this polynomial using the box method. You start out the same. Leading coefficient is other than 1. You multiply first times the last. That gives you 48. You list all the factors. You pay attention to your sign, the combination of signs that would get you there. You're looking for positive 13x. So you settle on the negative 3x and the positive 16x. But what you do with these, instead of writing them in the line like this, give yourself a 4-chamber box. The first term goes in the first box. The last term goes in the last box. I don't care about the sign down here. And then the 2 terms here that you selected go in either of these 2 boxes. So I'll put negative 3x here and positive 16x here. It's important that you keep the sign with the term, but I could have put negative 3x up here and a positive 16x here. It does not matter. Now I'm just going to look for the greatest common factor for these 2 chambers, basically going up. Greatest common factor going up, greatest common factor going across, and greatest common factor going across. So going up here, I could get an 8 out of each term. And whatever sign this is the sign that will sit between these 2 terms. Going up here, I can get a 3x out of each term. Now going across, I could get a 2x out of each term. Whatever this sign is the sign that'll be sitting between the numbers. I'll put it there, but you'll see how I write it in a moment. And here, the common factor is a 1. I can't get anything except a 1 out of each term. So the factored form is 3x plus 8 and 2x minus 1. You can see that's what we got when we did factor by grouping. It's in a different order, but when you multiply everything together, you would still get your original polynomial, so this is correct as well. You might want to put this negative just in front of that value. I'm just emphasizing whatever sign's here goes between these 2 numbers. You can see it's sitting right there. So you have this polynomial, leading coefficient other than 1. Multiply 4 times negative 10. This gives you a negative 40. You list all the factors. You pay attention to the sign. So you're looking for a difference of negative 3. You look down the list and you settle on positive 5x, negative 8x. Give yourself a 4-chamber box. First term goes in the first box. Last term goes in the last box. And the 2 terms that you settled on go in these 2. By the way, if you don't write the x here and the x here, you do have to remember to put the x here and the x here when you put them in the boxes. That's very important for identifying the greatest common factor. In this case, it's not critical, but when you get over here, you need that x in order to say x is a common factor. You need this x in order to say x is a common factor. And then you identify the greatest common factor going up, up, over, and over. So going up, I can get a 2 out of each term. Whatever sign you have here is the sign between the numbers, and I can get an x out of each term here. Now going across, I can get 4x out of each term. I can get a 4x out of here and a 4x out of here. Whatever this sign is the sign sitting between these two terms. And I can get a 5 out of each term here. So the factored form of our original polynomial is right here. And you can see it's the same factored form that we came up with when we used factor by grouping. It just so happens I put them in a different order, but it's the same value. If you multiply all this together, you'll end up with your original polynomial. You want to factor this polynomial. Leading coefficient is other than 1. So you multiply 3 times 12. That gives you 36. You list all the factors. Then you pay attention to the sign. How you can get there had to be positive times positive or negative times negative. It must have been negative times negative because you want a negative 13x. So that means all these signs are negative. The factor pair that will give you a negative 13x is a negative 4 and a negative 9. So you've settled on these two. Now you give yourself a 4-chamber box. Put the first term in the first box. You put the last term in the last box. And you use these two terms to fill in these two boxes. Again, it doesn't matter which one goes where. Remember to put the variable. Now you look for the GCF. I can get a 3 out of each term. This sign sits between the numbers. And here, for the coefficients, I can only get a 1, but for the variables, I can get an x out of each term. Now going across, I can get a 3x out of each term. This sign sits between the numbers. And going across, I can get a 4 out of each term. So the factored form of the original polynomial, x minus 3 times 3x minus 4. And you can see that this answer is the same as the one we got when we used factor by grouping. Again, I end up with it in a different order, but that does not matter. So it's really up to you which method you use. I think in general, factor by box is a little bit easier, a little bit neater. Some professors prefer factor by grouping. They might feel that this is a bit more mechanical.